Good morning, everybody.
Good morning.
Good morning.
We're here in 204 today, and we're going to be doing a little bit of a hands-on activity to help us understand the connection between improper fractions and mixed numbers. So I have asked you all to get a sheet of paper, and it's okay if it's like from the recycle bin, as long as it is the standard size piece of paper. I'm just going to go pass one out to all of the kids in the classroom, and then I'll give you some instructions on what to do with this paper, okay? Hang on. So you need some scissors today so that we can create some manipulatives, okay? We're going to create some manipulatives so that we can use them for our learning. What I need you to do with our paper first is take it and fold it in half. Fold it in half. It does not matter which way, and you guys have to stop the chatting so that I can hear if people from home need any clarification as well. So, I'm sorry. This is all I said was to fold it in half. So stop talking and just fold the paper in half. This is pretty basic. So that's one fold. Keep it folded. You're going to fold it in half again. Try to make it as crisp as you can. Then fold it in half again. So this is the third fold.
Time out. Where are you?
Fold it in half, Ryan. Sure, or the other way. And then one more fold so that you have a piece that's about 2 inches by 1.5 inches. That's about 2.5 inches. So you have a piece like this. It's like a mini taco. One more fold. And if you did it properly, crisply fold it. When you unfold it, how many pieces are there? Unfold it. How many pieces are there? 16. You should have 16 pieces, right? You want. Here's what you're going to do with these 16 pieces. 204, I told you I'm trading attention, respect, and cooperation for no homework, right? So you have to be quiet. You are cutting these 16 manipulatives out. We're going to use them to represent some fraction pieces, okay? So cut them out. What would be the easiest game plan when you have equal size pieces? Cut them in strips and then stack the strips so that you cut through all 4 layers at once instead of one at a time, one piece at a time. Yep, we need a pile of 16 little pieces, okay? Sure, you can do it that way too. And then you'll have to kind of layer them and nestle them to get them cut out. Again, that's going to take too long. Stack them, cut them in strips. That's going to take too long going one at a time like that. Yes?
Miss Mar, doesn't matter if they're like perfectly straight edges.
Nope, we're going just to use them to represent different fraction quantities. And I just want everyone to be using relatively the same tool to do so. So that's why I had us make use of a material that I'm sure we all have on hand here. So make your 16 pieces and show me you're ready with a thumbs up, okay? I have some digital pieces here. So here, I'm gonna make my 16 pieces, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. All right, I have 16 digital pieces and you have 16 actual pieces. In front of you, yep. I have 16 pieces. All right, let me try and write that one again. I have 16 pieces. Thank you. All right, now what we're gonna do first is I'm going to tell you the value of one piece. That way we can start to understand its value both as an improper fraction and a mixed number, okay? Ready? Each of the pieces right now in round one is going to be valued at 1/2, okay? So I have 16 halves, don't I? I have a pile, I have 16 halves. Each of them is worth 1/2. So my question is when I put them, if I'd like to put them in mixed number format, what am I going to do? I'm going to take those 16 pieces and put them in piles of 2 because 1/2 and 1/2 make what? 1 whole. So I want to see how many wholes can I make with this pile of pieces. So everyone take your pieces and start making little groupings that represent 1 whole. Now this round, it only takes 2 pieces to make a whole because each piece is valued at 1/2, right? So we've got 1/2 and 1/2. Ooh, it's getting there. This is pretty easy, but the point is that we converted the improper fraction, 16 halves, into groupings that show how many wholes we have. How many wholes do we have? And we were able to achieve this process through division. What we did was we took 16 pieces and we divided them into groups of what? 2. So we divided, right? But we divided with our hands. How do you divide procedurally on paper? How do you show division on paper? You have a dividend spot, right? And a divisor spot, right? So on paper, this is how you show division. You put your dividend underneath and your divisor out front. And then you ask yourself that set of questions, right? How many times does 2 fit into 16? And you would go, it goes 8 times, Mrs. Moore, right? And then at the bottom of your long division problem, there's a smiley face because there's no remainder this time, right? So do you see how 16 divided into 2 leaves you with the value what? 8. So what we're going to do now, I'm going to go back. Here it goes. Hold on tight. Near.
Whoa, that was cool.
I know. So this time, instead of 1/2, put them all back in a pile. I want you to pretend that each of those pieces is valued at 1/3. Okay? So you have now 16 thirds. How many do you have to put in each pile in order to make a whole? 3, right? Because 1/3 and 1/3 and 1/3 make 3/3, which is equal to 1. So now you better take your pieces and put them into piles of 3. And it doesn't have to be perfect or any particular shape, right? Just put your cards here in piles of 3. There's one left over. Dun, dun, dun. Which means you have a remainder, right? You have a remainder because on paper, I can see I have how many holes, guys?
5.
I have 5 whole groups, but I have 1/3 left over, right? If I did this long division style, procedurally, oh, this is really hard to write with the mouse. If I did this procedurally, I would see that 3 goes into 16, 5 full times, right? But then how many leftovers do I have? 1. That 1 is out of 3 parts. So I say that the mixed number that matches this improper fraction is 5 whole times and 1/3 left over. Yes. I'm eventually going to have you show me what the mixed number is. So just on standby. Yeah, I would show you 5 1/3, something like that. Okay. What if I said, take your groups 5 1/3 and put them all back into one group? What would it be? How many thirds would you have in your one group? 16, right? Like we had to start. How can I reason or develop a procedure for converting this mixed number back into improper fraction form? There is this technique, and it will make you mad. Mad because we don't like improper fractions. But sometimes we have to convert them to use them for different purposes. But it's going to make you mad. Why? Because you're going to multiply, then you're going to add, and you're going to keep the denominator. It's going to make you mad. Ready? 3 groups of 5. That means 3 times 5. What's 3 times 5, guys? 15 plus 1. Add the 1. What do you get? 16.
16.
Keep the denominator. What do you have? 3, right? Did it make you mad? No. But did you remember the trick?
Yes.
Yes.
The easy way instead of dividing it and finding this number, just think of numbers that equal 16 in this number form.
You can do that, but you can do that if they're tiny. I will tell you, you can't do that when they get like crazy big. Yeah, you can do that. Are you ready for another one? All right, back to basics. Get me back to the pile. La, 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 la.
That's so cool. Wow.
Back to basics. How many, I shouldn't say how many. What value should I give each piece this time? I'm going to call them each a fourth. I'm going to give them, they're each going to be worth a fourth, okay? So how many pieces make one whole this time? 4, you got it. Okay, so let's bundle them up. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. Ooh, no leftovers. So 4 whole groups, right? 4 whole groups with 0 leftovers, right? You don't have to write the 0 fraction part because 0 doesn't affect the value of the 4 in any way. But does the around the world mad trick work? What's 4 times 4? Plus 0. Still 16. 16 fourths, right? It still works. You don't have to put that 0 over 4. You can just use the whole number part. Is this starting to click? Okay.
Yeah.
Here we go. Back to basics one last time. What's the last one I'm going to try with you today? It's going to be fifths. I could, but fifths is the one that I'm going to finish with here. If I put a value of 1/5 on each of these squares, how many piles can I make? I got to put them in piles of 5. And when I'm putting them in piles of 5, what I'm physically doing is dividing them into piles, right? I'm dividing them into groupings of 5. This is division in action right here. I'm dividing with my hands. And I have 1/5 left over. So I can prove it procedurally on paper by dividing 16 into 5 parts. And what do I expect to get? I'm going to expect to get 3 with the remainder of 1/5, right? And that's what I'm expecting. Let's see if it happens. 5 goes into 16 3 full times. Subtract. Boop, boop. So we found out procedurally it's true. We have 3 wholes and 1 of the fifths left over. How can you check if you did it right? Here's a hint. Nee, 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 nee. That's how you check if you did it right. What is 5 times 3 plus 1? 16. Keep the denominator 5. okay? Now that you know the basic rules, let's apply it to some bigger numbers, okay? So set your pile of pieces off to the side. Homework, respect. Homework, respect. Which do you value more? No homework, respect. So here we go. First one. Let me see if my board's gonna let me write on it today. What do you think? Is that a magic day?
No, it's not.
First, I want you to, wah, wah, wah. Most of the time. It worked yesterday for me, but not today. 27 thirds. Okay? What would 27 thirds look like as a mixed number? What procedure would you do? You would say 27 thirds is nothing more than 27 divided by 3. Okay? Did you write it out? Hold it up on your board. Or type it in the chat box. Yeah, write the answer. Yeah, write the answer. So you have to go and divide 27 by 3, right? And what do you get? You get 9, right? It's just 9. The answer is just 9. Well done. 9. 9. All right, here's the fine. You want something harder?
Yeah.
58 thirds. 58 thirds. Shh. Procedure's the same. Numbers are different. 58 divided into 3 parts. You don't want to make 58 squares and put them in piles of 3. That'll take forever. So the procedure is divide. Use long division. How many times does 58 go into, or 3 go into 58? 3 goes into 5 once. Drop it down. Continue. Hold it up when you're done. You guys are different. Something's wrong. I'm not always going to give a nice, pretty, even number, but sometimes it happens, right? All right, see my chat box blowing up here. Some people are saying 19, Luke and Will.
I said 19.
Okay, let's check the math. 58 divided into 3 parts. That's a 1. They can't hear at home. 3 goes into 28. 9 whole times. But how many leftovers? 1. So you should have 19, but don't forget about your remainder. 1/3. 19 and 1 left over. 1 what? 1/3 is left over.
Let's do another one.
Again.
Oh,
204. Close it. 108 fourths. Ooh, why do I keep picking nice even numbers? What's going on in my brain today? 27 on the spot. Fine, I gotta pick something a little bit. We have to get a fraction involved here. How about this? 108 fifths. There we go. That'll give us a mixed number. 108 fifths. Go for it. It is not the same thing because you're dividing it into 5 parts. 5 parts, not 4. So get after that division. 108 divided by 5. I have the best handwriting on the computer.
Or just funny.
Oh my goodness, this is atrocious. 5 goes into 8 one time, but it looks like I have some leftovers, right? So 21 whole times, but 3/5 left over. How did you do? Okay, I see some people writing R3, which is definitely the way that you did it when you learned about long division. You learned that the remainder was 3, but now you know that the remainder represents a portion of the dividend that's still there, right? So you have to say out of how many parts? 3 out of 5 parts. 3 was your divisor, okay? Now we're going to go the other way. I'm going to give you the mixed number, and what are you going to give me? You're going to give me the improper fraction, and it's going to make you go mad. Okay, here's a little reminder. Okay, multiply, then add, keep the denominator, right? 35 plus 2, 37 over 5. You got it. Was that pretty easy? Here we go. Fine, bigger one. Come on. Let's go. How's it going, everybody? 99 eighths? Yes? Why? 8 times 12, 96, plus 3, 99. Keep the denominator. Nice. Thank you for typing in the chat box, guys. It makes me know how it's going at home, or show me on the screen. Okay, are you ready for the culminating skill? That means we've built up our understanding of how to add fractions, how to subtract fractions, what are mixed numbers, what are improper fractions. Now comes the point where you're going to add and or subtract mixed numbers. Mhm. So as an example, I'm just going to do a basic one here to start. 3 and let's say 2/5 plus 1 1/10. Okay. You have mixed numbers here, but the rule about adding fractions still apply. There are fraction pieces involved, right? What do you need when you add or subtract fractions? What do you absolutely need? Common denominators, right? And right now you don't have them. How can you get them? There's a couple of different ways that you can structure this problem. You can keep them as mixed numbers and just fiddle with the fractions, or you can do the around the world trick to both numbers and handle them as improper fractions. And it's totally your call. If you go the improper fraction route, you're going to have a bigger numbers to deal with, and then you'll have to convert it back at the end. But it's, some people like only looking at one term and not a mixed number. Okay, I'm going to do it the standard approach is keeping it in mixed number format and just converting the denominators to be the same, right? So what's the common denominator between 5 and a 10? It's going to be 10. So how do I get a 5 to look like a 10? I have to multiply this fraction team times 2. So 2/5 becomes 4/10, right? This fraction is already dressed for school. He already has his uniform on, right? So he does not need to get ready at all. Now I combine fraction with fraction, whole number with whole number. What would 3 plus 1 more be? 4. And what would 4/10 and 1/10 be? 5 what? 5/10. Yeah. So someone said, hey, simplify, pull a factor of 5 out of both of them, divide a factor of 5 out of both of them, which would leave you with 4 1/2, which is the simplest base form of the answer. Is 4 5/10 the true answer? Yeah, sure. But we can simplify it down to a base fraction, which would be 4 1/2. All right, couple more. And then I promise you won't have homework because you're working real hard here today for me. I said you will not if you keep working hard here. We've got like 5 minutes left. We can do it. We can do it. Here we go. 3 5/6 plus 2 11/18. Okay. Your call. Do you convert them both into improper fractions, or that looks like it's going to be a big number? Do you just handle them as mixed numbers, common denominators for fractions only? All right. Hey, and if you like to arrange it vertically instead, I know, Ryan, you said you like that. If you want to arrange it vertically instead, you can do that.
So
right?
what would it be if it were
This is the vertical setup, right? You still need what? Common.
denominator?
You still need common denominators between 6 and 18. What's the common denominator between 6 and 18, boys and girls?
3.
Not 3. No, that's a common factor.
18.
What's the common multiple they share first? 18. So let's move it to the 18ths, right? So let's make them look like 18ths so that they have the same uniform on, right? We want them to have the same uniform on so that we can combine them. This one doesn't need to be adjusted, right? This one does need to be adjusted. How do I get a 6 to look like an 18? What factor do I need to apply to it? A 3. So 5 times 3 is going to be 15. Keep the whole number in place. Now I just go about adding fractions with fractions, whole numbers with whole numbers, okay?
Awesome.
What would 15/18 plus 11/18 be? What would 15 and 11 more be? 26/18? Uh-oh. What are you thinking? That's bigger than 1, isn't it? That's bigger than one whole group. So how can we adjust this mixed number so it shows a standard value answer? We're going to have to regroup that fraction a little bit and then put the extra group of 1 into the ones column. Kind of like when you're adding together a couple of numbers like this, and you get too many here in the ones column, what do? You regroup, right? You regroup. So what we're going to do with this fraction is we're going to regroup them. How many would make up one whole in this fraction? How many pieces would make up one whole? Brindley?
1.
How many of these fraction pieces? So what represents a whole with this fraction? If it says it's out of 18, then how many pieces do I need to make one group? 18, right? 18/18 make 1. So if I say 26/18 is sort of like saying I have 18/18 and how many extra 18ths? What's the difference between 26 and 18? 8, right? So I have 8 leftovers, right? Hang with me here. I'm not done. I'm not done. So what would 18/18 be regrouped as?
1.
A 1, right? So what would 1 plus 5 be? 6. And what would my leftover fraction buddy be? 8/18, right?
And you're not.
Whew. We could simplify it a touch too, but we're still working on that skill. We're still working on that skill. So if you are able to get to 6 and 8/18, that is a really great progress for today. It should be 6 and 4/9 if you reduce it down just a little bit more. Okay, we're gonna work more on mixed number operations on Tuesday. I don't have class with the in-person kids on Monday. We're going to reconciliation on Monday. So we have a tight day, but I do have class again with you on Tuesday. I'm going to meet with you guys on Monday just alone and continue to push a little farther with this. You do have a quiz coming Thursday, okay? The quiz will include adding fractions, subtracting fractions, adding and subtracting mixed numbers.
What do we do with the paper?
Okay, so what we did in class today was just guided support, guided practice. There's nothing for you to turn in if you were in attendance here with me today. If you're watching the recording because you did not make it live, then please take a picture of the classwork that you did with me today.
I'm
But
getting pretty good at it.
TGIF, we made it. We're halfway through Friday. Have a great weekend, and I'll see you next week, okay?
Miss Moore, I already did the quiz. This is the first time I ever learned it.
Bye. Bye, everyone. Bye. See you next week.
I'm not like the best at it yet, but I'm doing pretty.
It's like all of a sudden, all of these hard they click and they're all related.
And then these
You can recycle the pieces. I don't need the pieces. Was that a lot of work today?
Like, it was fun. It's fun. It got tiring at the
I like to work you hard. Yes. It's like brain exercise. In the recycle bin?
What? Yes, you are.
Hey, let's get cleaned up for lunch.